Look at almost any truck carrying liquid: fuel, milk, chemicals, even liquefied gas. The tank is curved, but why? A box would be easier to build. It would sit neatly on the trailer, and it could use nearly every centimeter of available space. Yet engineers deliberately choose a shape that appears to waste it. That curve isn't decoration. It's what stops thousands of liters of moving liquid from tearing the tank apart. And the real reason goes far beyond pressure, because the shape must also fight weight, corrosion, violent liquid movement, and one of the most dangerous forces a truck driver can't even see. Imagine filling a perfectly square metal tank with liquid. When the tank is stationary, the liquid pushes outward against every surface. The deeper the liquid, the greater that pressure becomes. Now accelerate the truck, brake hard. The load inside is no longer just sitting there. It's moving. Thousands of kilograms of liquid surge against the walls, concentrating force wherever the structure changes direction. And that's where a square tank has a serious weakness: its corners. Every flat wall tries to bend outward, but at the corners, those forces collide. Stress becomes concentrated along the seams and welds. That means thicker walls, heavier reinforcement, and more complicated construction. A curved tank handles the same force differently. Instead of allowing pressure to attack isolated points, the curve spreads that force continuously around the shell. There's no sharp corner where stress can gather. The load flows through the structure. This is the same reason pressure vessels, gas cylinders, and submarine hulls are curved. A circle doesn't have a weak side. Push outward from the center, and every part of the wall helps resist the force. A curved shell transfers much of the load around its surface. For a tanker carrying pressurized cargo, this difference is critical. A cylindrical tank can withstand internal pressure using less material than a comparable rectangular container. And less material means less empty weight. That matters because every truck has a legal weight limit. The heavier the tank itself becomes, the less product it can carry. So engineers face a simple economic equation. Every unnecessary kilogram of steel or aluminum is one less kilogram of cargo. The round tank isn't just stronger, it earns more money on every journey. For a given amount of enclosed space, curved shapes can use less surface material than box-like shapes designed to resist the same forces. Fewer reinforced corners, fewer high-stress seams, less structural bracing, and fewer places where fatigue cracks can begin. That also makes the tank easier to maintain. Cleaning systems can reach the walls without debris becoming trapped in 90-degree corners. Liquid drains more naturally from a curved interior. That's especially important for tankers transporting milk, edible oils, and other food products. But this raises another question. If circles are so strong, why do many road tankers look slightly flattened? Look closely at a typical fuel tanker. Its cross-section may not be a perfect circle. It may be oval, elliptical, or shaped like a rounded rectangle. That's intentional. A perfectly circular tank places some of its volume high above the road, but a lower tank keeps more of the liquid closer to the ground. That lowers the vehicle's center of gravity. The engineers are making a trade-off. They preserve curved walls to avoid severe stress concentrations, but flatten and widen the overall profile to improve road stability. So the real design rule isn't that every liquid tanker must be perfectly round. It's that its walls should avoid large, unsupported flat surfaces and sharp structural corners. But even the strongest tank shape can't completely control what happens inside it, because liquid doesn't behave like ordinary cargo. So they place another structure inside the tank, one most people never see. Inside many liquid tankers are metal plates called baffles. They interrupt the liquid's movement. Instead of allowing one enormous wave to travel through the full length of the tank, baffles divide that movement into smaller, weaker flows. Openings in the plates still allow the liquid to pass through during filling and unloading, but they slow the sudden surge created by braking, acceleration, and cornering. Some tankers also use sealed bulkheads that divide the cargo into separate compartments. This can reduce movement and allow the truck to carry different products during the same journey. But there's a design challenge. More internal structures mean more weight, more welds, and more surfaces that must be cleaned. Some liquids are also too thick to move effectively through heavily baffled tanks. That's why tanker design changes depending on the cargo. A tanker carrying ordinary fuel at low pressure may use a wide, low oval profile for road stability. A tanker carrying pressurized gas needs a more circular pressure vessel because internal pressure becomes the dominant threat. A tanker carrying hot asphalt may use a smooth interior with insulation to keep the cargo flowing. Food-grade tankers prioritize drainage, sanitation, and polished internal surfaces. Dry bulk tankers carrying powders may use cylindrical bodies and cone-shaped outlets so gravity can help unload the cargo. Even the ends of the tank matter. Flat end caps would act like giant metal plates being pushed outward. So pressure tankers often use curved or dished ends. Again, the goal is to remove weak flat surfaces and spread force through the shell. Every curve has a job, so liquid transport trucks aren't curved because round tanks simply look aerodynamic. Their design is a calculated compromise between pressure, strength, weight, cargo capacity, sanitation, and road stability. The curved shell spreads force. The lowered profile keeps the load closer to the road. The internal baffles fight the liquid's momentum, and the specialized ends prevent pressure from attacking a flat wall. What looks like a simple metal container is actually a moving pressure structure, carrying a load that never completely sits still.